Why do I start spinning when I turn this bicycle wheel? Well, it's due to something called conservation of angular momentum. To understand this, we first need to know how angular momentum is calculated. Angular momentum is calculated by the equation L equals I times omega, or angular momentum equals moment of inertia times speed of rotation. The moment of inertia is calculated as the sum of the mass and the radius squared of every different point in the rotating object. But that's too complex, so instead we can use this image to see different formulas depending on the shape of the spinning object. For example, the inertia of a solid sphere around any diameter is 2 times the mass times the radius squared divided by 5. The speed of rotation can be found by plugging the object's radius and velocity into a meters per second to radians per second calculator online. Okay, but why do I spin? In the demonstration, we'll call the total initial angular momentum on the vertical axis L. After I turn the wheel, its force is reversed to negative L. This makes me start spinning at twice the speed but in the opposite direction, making the total, or resultant, momentum cancel out to L, just like before. This is called conservation of angular momentum and happens because of Newton's third law. And now you know